Okay, in the last video we talked about what the discriminant was, b squared minus 4ac, how you find it. That's the b, that's the a, and that's the c. And then we talked about the things that the discriminant tells me. Now I want to talk about how you read this chart so that you can understand. When you find the discriminant, it will fall in one of four categories. It will be 0, it will be negative, it will be a positive perfect square, and I give you examples: 1, 4, 9, 16, 25, 36, 64, 49 I missed, 64, 81, 100, 121, 144, you get the gist. Or a positive non-square, like 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, etc. So the way you use this chart is when you find the discriminant, you figure out which row you're going to read. If the discriminant is 0, it means that your parabola will sit so that its vertex sits exactly on the x-axis. Okay, this one opens up, but it could just as easily open down. If your discriminant is 0, the vertex is on the x-axis. So here is two examples. If the discriminant is negative, it will not cross the x-axis at all. It can be up here in the sky or down here in the sky, but the parabola will not cross the x-axis. If your discriminant is negative, the parabola will not cross the x-axis. If your discriminant is positive and a perfect square, then your parabola will cross the x-axis at fairly pretty places. And by that I mean it's going to cross at a whole number, or it's going to cross at a pretty fraction. Okay? If your discriminant is positive but not a square, it's going to cross at a weirdy place, like 6.37946241398764, etc. Okay? So the discriminant, one of these four types, will tell you, does it cross the x-axis at all? Okay? Now, the discriminant also tells me the number of roots. Roots are where it crosses the x-axis. Quadratic equations always have two answers. And those answers are where it crosses the x-axis. If your discriminant is 0, it doesn't actually cross the x-axis. It hits the x-axis and it turns around. So that means you have the same answer twice. It's one double root, meaning you have the same answer twice. If your discriminant is negative, it doesn't even cross the x-axis. So you have no real roots. Okay? To have a root, a real root, it has to cross the x-axis. If your discriminant's negative, it doesn't cross the x-axis, so there's no real roots. If the discriminant is a positive perfect square, then it crosses the axis twice, so you have two real roots. And they're kind of pretty numbers. If it's a positive non-square, it crosses twice, so you have two real roots, but they're not really pretty. Okay? So the number of roots, if it's 0, it has one root that happens twice, so we call that a double root. One double root. If it's negative, it doesn't cross at all, so we have 0 real roots. If it's positive, it either crosses twice in pretty places or twice in non-pretty places, but we have two roots. Okay? Now, the type of roots. If it touches the x-axis, if the discriminant is 0 and it just touches the x-axis, it's guaranteed to be a rational number, fraction or a pretty decimal, like 0.1. If it's negative, your answers are imaginary, meaning they're not real. They have eyes in them. If it's positive and a perfect square, then it's rational, and it's a fraction or a pretty decimal, because 0, believe it or not, is a perfect square. 0 times 0. If it's positive but not a perfect square, you're going to get irrational answers. They're still going to be real, but they're going to be weirdy decimals. And I gave you 2 examples, the square root of 2 or the square root of 5. Okay. Then the last column says, how can you solve the quadratic equation? In other words, how can you find the roots? Well, if the discriminant is 0, the graph will reveal the answer as the vertex. If the discriminant is 0, you can factor it by PST. If the discriminant is 0, you can complete the square. Or if the discriminant is 0, you can do the quadratic formula. So if you work out a problem and the discriminant is 0, you have 4 ways to answer it, to solve it. Okay? If the discriminant is negative, graphing won't help, okay, because it's not even going to cross it. If the discriminant is negative, the thing won't factor. You can only factor if the discriminant's positive. If the discriminant is negative, you can complete the square or you can use the quadratic formula. Okay. Now what about if the discriminant is a positive perfect square, like say for instance 25? Graphing might work, but it could cross at a fractional place that you couldn't find. Now my picture here crosses at neat places, but it might cross at a fraction. If you have a positive perfect square, this thing is factorable by tricks or general trinomial, so you could actually factor it. You can complete the square or you can do quadratic formula. If it's a positive non-square, graphing won't work because the answer is going to be weirdy, like the square root of 2 or the square root of 5 or the square root of 7. It will not factor if it's a positive non-square, but you still can complete the square or do quadratic formula. Notice on all 4 of them, completing the square and the quadratic formula always work. Sometimes completing the square is difficult, but it will always work if you do it correctly. Okay? So this video was just to explain to you this chart. Okay? Now the third and last video for today will show you how to actually work them.